Hi everybody, this is a guided walkthrough for the YourWAF challenge over at VulNyx.com. So the first thing we need to do is we need to do a port scan of the remote server, and we see here that we've got an IP address. So we're just going to be using this IP address to do our scans. So we're going to run nmap, which is everybody's favorite tool for doing network scanning. We're going to run it very verbose. We're going to run it at very quick speed, but not too quick. We're going to run versioning information and common scripts against whatever services we find. We're going to run it against all the ports, and we're going to run it on this IP address. Okay. So the reason why we run it very verbose is that we can actually get output from the program before the program finishes scanning. So we see here that we got 3 ports that we've identified. We got port 80, which is unencrypted web pages. We got port 22, which is SSH, which is remote login, and we got port 3000, and this is running a Node.js application. So Node.js is JavaScript server software. And the first thing what we're going to do is we're going to investigate port 80. So port 80 is the unencrypted web page, and we get 403 forbidden. So that's kind of unusual that nmap is going the landing page for a web application is forbidden. But we're going to go ahead and go over to the web page manually over here. So 192.212.15. Okay, it says unable to connect. Unable to connect, an error message during a connection to this. So what we see here is that the server tried to redirect us to a domain. So the domain in this case is www.yourwaf.nix. This isn't part of our host file, so we're not going to be able to access this domain. What we're going to do instead is we're going to copy this, and we're going to write this into our local etc host file. So we do sudo nano etc hosts, and what we're going to do is we're going to paste in yourwaf.nix, which is a domain. We're going to associate it with a specific IP address. So the IP address for our box is 192.168.212.15, which means that every time we try to access this domain, www.yourwaf.nix, it'll reference this IP address. So unless this is done, you are not going to be able to access this on your local machine. So another thing we're going to do is we're going to take the base domain over here, yourwaf.nix, and we're going to add this to the etc hosts file as well. So yourwaf.nix without the www dot. We're going to save this out, and then we're going to go back to our web browser. Okay, so we're going to try to reload this page from from HTTP, but not HTTPS. And we're going to see that we've identified a web application firewall. So your favorite web application firewall, mod security. So let's talk about the implications of a web application firewall on the web application that you're testing. Okay, so let's talk about what web application firewalls are, because this is the main crux of the challenge today. So web application firewalls are network appliances which filter HTTP requests to prevent automated scanning and common web attacks. So what does this mean? So the common web attacks that the web application firewall might protect against are things like file upload attacks, injection attacks, login brute forcing, etc., etc. A bunch of different stuff. Okay, so depending on how the WAF is configured, it could filter requests based on IP address, post request body data, HTTP header contents, or many other factors. So it basically prevents your requests from going through if it thinks that the requests have bad stuff in them. So in this challenge, the web app landing page implies that mod security WAF is being used. So mod security, what is this thing? So mod security is actually it's a very common web application firewall, and especially for Apache servers, Nginx servers, but most of the most common servers, you'll see mod security around. So when we try using a common security tool to scan the web server, we see that our requests are blocked. So we get a 403 forbidden error over here, and that's using the WhatWeb scanning tool. So if we go over to here, we do WhatWeb over on www.yourwaf.nyx. Okay, so when we run this tool, so WhatWeb, it gives us the 403 forbidden title. But the thing is that if you manually access the landing page, where is the manual page? So the manual page doesn't give you a 403 forbidden. So why does it give you 403 forbidden when you use the WhatWeb tool? And over here we used Nmap, and if we use Nmap to just scan port 80 on the server, so this is YourWAF.nyx. We're going to see that Nmap also gets 403 forbidden. So what is the common link between WhatWeb and Nmap? And what is the difference between WhatWeb and Nmap and our regular web browser? Okay, so when we try using common security tools to scan the web server, we see that our requests are blocked. And this is because the web application firewall is blocking on user agent headers. So by default, web security tools send a user agent header with each of their requests to identify themselves when making requests to the server. So for example, if we use WhatWeb, it'll send this user agent header, WhatWeb something something. If you use FFUF, which is another common security testing tool, it sends this user agent header, fuzzfasteryoufool. And if we use GoBuster to do some directory busting, it sends the GoBuster user agent header. Okay, so how can we confirm this? So we can confirm this by doing this. So if we run WhatWeb, but we actually give it a custom user agent header, it doesn't matter what it is. It just matters that it's not the default one, which is WhatWeb. So if we send it with the user agent HackerFrogs instead, then we get a 200 OK instead of a 403 forbidden. So a common way that web application firewalls prevent automated scanning of the web app is to filter all requests that contain user agent headers with the names of web app scanning tools. So this is something that you learn when you do red teaming. When you do red teaming, they often have to deal with web application firewalls, and they have to make sure that their tools are not advertising themselves as hacking tools, because otherwise it's really, really bad. So if you're using common tools like Nmap, like GoBuster, like Nikto, all this stuff is going to get blocked by the web application firewall because it's looking for that user agent header. So we can spoof user agent headers to trick the application into letting our stuff through. So all security tools include the option to supply an arbitrary user agent header, so we can bypass this type of WAF filtering. So not in this case, we just need to ensure that the user agent value is not one on the deny list. So almost all random values will work. So we can use user agent HackerFrogs, We could use user agent Firefox. We could do Chrome. It doesn't matter. It just has to not be one on the deny list. Okay. So the next thing that we're going to do is we're going to use FFUF with the spoofing to do subdomain enumeration. So now that we know which user agent values to not use, we can fuzz the subdomain with FFUF. And okay, let's go ahead and do that. Let's see, brute force attack. So FFUF is a tool that we can use to do subdomain enumeration. We can do all sorts of fuzzing with FFUF, but it's very good for subdomain enumeration, trying to find additional subdomains after you have an initial domain. So for example, the website that we're accessing right now, where is it? You can get rid of some of these tabs because there are way too many of them. So the domain that we're using right now is www.yourwaf.nix. So www is actually a subdomain. And we can try to look for other subdomains that are not www using FFUF. So we're going to use FFUF. We're going to get a list of 1 million of the most popular subdomains. We're going to fuzz the yourwaf.nix domain, and then we're going to submit a custom user agent. Because if we don't submit a custom user agent, then we're going to find that everything gets blocked. We just need to make sure that the user agent is not the default one for FFUF. Otherwise, bad stuff is going to happen. Okay, so we immediately find that www is one of the subdomains. So this is our good control one. We also discover maintenance over here. So maintenance is another subdomain that we could enumerate on the web app. So these are the only two that exist, so we can just get out of FFUF now. What we're going to do now is we're just going to add maintenance to the etc host file. So we got yourwaf.nix www, and we've got the regular old yourwaf.nix. We're going to add maintenance.yourwaf.nix to the list, and then we're going to save it out. And then we're going to access that endpoint. So we can go back to our web browser. We're going to replace www with maintenance. And here we've got an interesting web application. So if you don't speak Spanish, you can always Google Translate this. So where are we? So Spanish. Running commands. You can run commands for the server maintenance below. So this application it's running a pretty dangerous function over here. So basically what we can do is we can type in Linux commands and it gives us the output. So what is going on? Okay, so we found the maintenance subdomain. We added it to our etc host file, and then we accessed the maintenance subdomain. Now we've got a new problem. So the web application firewall is also doing command injection filtering. So the maintenance endpoint hosts an OS command function, but it filters commands based on denied listed patterns. So it'll give us, every time we give something that the web application firewall doesn't like, it'll give us a forbidden message. So over here, anytime we give something sensitive, so we try to LSLA to get the current directory listing, it'll give us a forbidden. So what is the application actually filtering on? So this could be the web page filtering, but it's actually the web application firewall filtering. So let's talk about this. So OS command filter bypass. This is what we need to do to get access to the system. So we can use the, so if we try to access bin bash, it's not going to let us. Let's demonstrate. So over here, we'll go back. We'll try to run bin bash, or just try to run bash by itself. Just type in bash e something. Probably give us a forbidden because it doesn't like bash e for execute. If we specify bin user bin echo, we try to echo something out. Test. It says forbidden because it doesn't like the full file path for the echo command. But what we can do is we can do something called substitution or character substitution. And in Linux, you can do character substitution with the question mark. Let's talk about that. So we can use the question mark special characters to substitute characters in file names, which allows us to run whatever commands we want. So if we, instead of using bin bash, we do b $n. So because there's nothing else in the directory except for, there's no other choices except for bin and b something s something, it's only going to resolve to bash. So same thing with echo, we just need to substitute a couple of characters in there so that it gets past the filter. So the thing is that we're allowed to run, for some reason we're allowed to run the base64 command. So the only reason why we're able to actually get access to the server in this case is because they forgot to filter out the base64 command. I suppose we could also substitute the base64 command as well. We can run arbitrary commands as long as we base64 encode them first and then pipe them into the bash command. So in this case, what we want to do is we want to get a reverse shell or shell access to the system. So this is what we're going to do. Let's see, remote access. So what we want to do is we want to get a reverse shell on the target. We're going to run rlwrap with netcat to run a reverse shell listener on port 443 on our attacker system. So we got that running. The next thing we want to do is, well, we can do an experiment first just to see if we can run a command. So we want to run a command like who am I? So if we want to get the system to run who am I for us, we would have to base64 encode it into this. So if we base64 this command, we can go into the application. We can replace bin echo with these substitutions commands here, and we can paste in our base64 encoded message. We would then pipe it into base64 decode, and then pipe that into bin bash. But of course, we can't do bin bash. We have to do substitutions in here. Whoops. I have to do substitutions and -e to execute the command. So if we run the entire command here, then we actually run the command who am I, because it was been base64 encoded and then decoded and then run by bin bash. So from here, we're going to try to get our reverse shell connection. So let me grab that command. So the command is actually this one. Let me decode it for you. Okay, so what this is, it's this command. So sh-i and then was that greater than and dev device over here with an IP address and a port, and then redirect everything into standard in. Wait, is that standard in or standard out? Standard in is 0, standard out is 1, standard error is 2. But anyways, this is a reverse shell connection command that reaches out to this IP address, which is our attacker machine. So our attacker machine is this IP address right here. on port 443, which we've set up with the netcat listener. Okay, so let me get the whole command. So the whole command looks like this. So we run user bin echo, echo out the base64 encoded reverse shell command. We decode it with base64 decode, and then we run bin bash to execute it. So we go to the application, paste that command in. Okay, so we run the command, and we see that the command hangs. It hangs the server, which means that it's probably in the process of doing something. If we go back to our remote access window over here, we see that we've gotten the connection from the server. So this is the server address. Actually, wait, this is not the server address, this is our address. This is the server address here. If we ask who am I, we are the www data user. Typically what we do first is we try to figure out if we can upgrade our shell using something like Python. So we can use Python to run a command to import the PTY module, then spawn in a bin bash terminal, which gives us a slightly better terminal now. Okay, so at this point, let's call in Scary Hacker Voice Man to talk about how we broke in.
Hey everybody, it's me, Scary Hacker Voice Man. Scary Hacker Voice Man comes in every time we break into a server, and we just broke into this one. Well, Mr. YourWAF administrator, you thought you were clever by configuring your web application firewall to filter on user agent headers. That was, well, it wasn't a big mistake, but we were able to bypass it by giving our own custom user agent headers. Then we discovered your maintenance subdomain, which also had a dangerous function, which lets us run Linux commands. And that was also filtered all to heck. But we managed to find a way to bypass those restrictions and then get a reverse shell connection on your machine. Maybe you knew about the security flaws in your system, or maybe you decided to accept the risk. Well, you accepted the risk. Ha 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 ha. And now we're in.
Okay, so now we're in. We just need to figure out what we're going to be doing next. So if we take a look at what we've got, we can do a bunch of different techniques for trying to figure out how to do our privilege escalation on the system. If we go over to the home directory, we can see that there's another user on the box called the tester user. We're currently running as the www data user, and if we go over to the opt directory, which has optional software, we see that we've got a node app directory in here. It's a little bit unusual, so we can enter that directory. And we see here that there's a script. There's a very conspicuous script here that's owned by root, and it's owned by the copylogs group. But there's also the code that runs the server over here at server.js. So if we read that file, we see at the top that this is a Node.js server because this is running Express. It's running on port 3000. There's an API token over here that we can use. And there's also an endpoint here called, what is it called? It's called read file. So there's an endpoint called read file that uses the API token. And what we can do is we can read arbitrary files on the web server if we use local file inclusion. local file inclusion, the LFI vulnerability. So let's talk about that method of privilege escalation. So privilege escalation captured API key. So we see that the server code for the app is running on port 3000, and we can capture the API key. So according to the code, there's a special function at the read file endpoint, which lets you read a file. Since the Node app is being run as root, we could potentially read any file in the system. So what we need to do is check here, ps aux. We see that the where is it? Node. Actually, grep node. Yeah, so the node application is being run as the root user, which means if we're able to use the read file endpoint, we should be able to read any file on the system. And well, I mean, here's the thing: we don't know where the files, we don't know what sensitive files might exist on the system, but we do know that there's another user on the system that's the tester user. And if the tester user has any sort of SSH keys, we would be able to read those by using privileged file read. And this is how we would do it. Okay, where are we? Let me get the command. Okay, so this is the command we're going to be using here. So we use a curl request to the application on port 3000, and the read file endpoint. So it's checking for an API token. So we supply the API token URL parameter and then the value of the API token. We also need to supply a file to read in this case. So everything here is specified in the code. So where's that code? So app.get read file check API token. Let's see. It's looking for file, and it's also looking for API token. Where is it looking for API token? Check API token. Okay, so query API token. This is where we know to supply the API token URL parameter. So okay, so what we're going to do is we're going to supply the API token. We're going to supply the file. We're going to use local file inclusion escape to access the tester user's SSH key. So when we give the command, we read the tester user's SSH key. We can go ahead and copy this, and we can create our own SSH key to try to log in as the tester user. So there are a couple of steps to get this done. The first thing would be to create the id.rsa file, which is the typical SSH key file. We need to make this, we need to modify the file permissions on this because they're a bit too loose right now. So typically what these keys have to have for file permissions is just read permission for the file owner. So what we do is we do chmod 600 on id.rsa. After that, we can try using this to log in as the tester user. We would do ssh tester at YourWAF.nyx and specify the id.rsa file. Okay, it's going to ask us for the passphrase. We don't know the passphrase, so we can't answer this question. So what we need to do next is we need to crack the IDRSA key file. We need to crack the passphrase, and this is how we're going to do it. So we need to run John the Ripper to crack the passphrase. So the first part to do that is to run SSH to John, which is a utility tool, to extract the hash from IDRSA. So run that and then output that to tester.hash. Okay, and then after that, tester.hash has a big hash that we can feed into John the Ripper, the password cracking program. So we run John with a specific word list, -- word list equals user share word lists rocku.txt. This is a very commonly used word list to compare against cracked passwords. To crack passwords, rather. It has 14 million of the most common passwords on it. And we're going to specify tester.hash as the hash file that we want to test against. Okay, so that's trying to crack the hash over at tester.hash. It's comparing the hash against all of the passwords on rocku.txt, the really, really big password list file. Okay, so we can use this this passphrase that we cracked to get into the system. So we don't need remote access as this user anymore, so we're just going to quit out of this session. Get out of here. Then we're going to SSH in tester at YourWAF.nyx using IDRSA. Okay, what is the passphrase? It's a WAFACO, and we're in again. Okay, I mean we've got our user flag over here. We would usually be collecting these. I'm not too concerned about collecting user flags and root flags. I'm more about the educational value. Okay, so the interesting thing about our user now is that in the op directory where the node app is, there's the copylogs.sh script here. And if we take a look at who owns that script, the copylogs group owns that script, and our user belongs to the copylogs group. So we own that script. So the other thing about this is that, well, this script over here is being used as a cron job. I guess the modification time doesn't really tell you either, but if you take a look at the contents of copylogs, you get a feeling that this is actually something that's going to be run on a very regular basis because it's copying over files from the logs directory over here. But so this is our indication. So if we get the indication that this is actually a file that is being run at regular intervals, what we can do is we can just copy our own command into it. And well, and because we belong to the group owners, we can just edit this thing directly using something like nano. If we want to be stealthy, we would be adding to the script instead of overwriting the script. But in this case, we don't really need to be very, very sneaky about it. We can just run a command like this. And that's going to create our reverse shell command to our machine again. Although I guess if you were to keep this around, well, people might be able to find these logs as well. Anyways, copy that over and then get out, start up your reverse shell listener, and 3, 2, 1, we have a root shell because the script is running as root. Okay, who am I? Root. That's great. So we can do this.
What are you? I'm system root.
And let's move into the root directory to get our flag. So the flag is over here, and because we've got root access, we've essentially finished the system. So I guess let's talk about how we compromise the system before we get out. Actually, let's talk about the last privilege escalation step we did. Okay, so the last privilege escalation step involves hijacking the root cronjob script owned by the copylogs group to which our user belongs. So the thing is that the cronjob isn't visible to regular users, but if you take a look at the running processes, you'll see that it is being run over here by the root user. So bin bash opt node app copylogs.sh. Okay, so all right, so everybody, that was a guided walkthrough for the YourWAF challenge over at VulNyx.com. So if you enjoyed this guided walkthrough, please click on the like and subscribe buttons on the video and leave a comment underneath the video. But until next time, HackerFrogs out.
Hey there, HackerFrogs! Are you enjoying this workshop? Learning new concepts and skills? If so, there's a way you can support the channel, and it's totally free. Just click on the subscribe button below the video. Also, click on the like button. And if you have questions or comments on this workshop, please leave them below the video. Thanks for listening. And now, back to our scheduled programming.